So we've talked a little bit about solids or solutes dissolving in solvents and saying, oh, well, they're soluble or miscible. But we haven't really talked about what is this property of solubility. And again, this is going to be a little bit of an introduction, and then you're going to go a lot more in depth into it in Chem 102. But solubility is just simply a measure of how much a solute will dissolve in a certain amount of solvent for a particular solvent. And this is commonly measured in something known as molar solubility, which will have units of moles per liter. And you look at that and say, wait a second, that's molarity. It's the same units, but it's basically saying I can dissolve X amount of solute in Y amount of solvent. And that number will change depending on a lot of things. It will change depending on the solvent. Different solvents will dissolve solutes differently. It'll change on the identity of the solute. It can change on temperature. And what we'll find even later, it can change on pressure if you're dealing with gases. So that molar solubility is kind of flexible depending on the conditions. And sometimes you might see it in units of mass per volume. So sometimes you might see grams per liter or milligrams per liter. It just depends on how it's reported. So let's talk a little bit about the different types of solutions that you can obtain by adding various amounts of solvent. So we're going to take a little cup of water and we're going to add some sodium chloride to it. And if it all dissolves, so I got sodium ions around here and some chloride ions. If it all dissolves and nothing, the salt doesn't like settle out and precipitate on the bottom, we call that unsaturated. That just means we haven't reached that maximum solubility yet. So let's add some more sodium chloride. So we add more, and so there's more sodiums, more chlorines. And eventually I reach a point where I cannot add any more sodium chloride and have it dissolve. When you reach that maximum solubility, that's called a saturated solution. And here's what happens. So here at this point, like, I don't know, well, is it still unsaturated or have I reached that point? Well, I'm going to add a little bit more salt. When I add that salt, it doesn't dissolve. I'm just going to put the same amount of sodium, the same amount of chloride. And then at the bottom, you kind of see some clumps of solid down here. That's undissolved sodium chloride. That is a saturated solution at this point. I've reached the maximum amount of solubility. Anything that I add more will not dissolve. And here's the key thing I want to note about a saturated solution. It looks like nothing is happening. So, for example, if you were to take a small glass of water, add some table salt to it, and get to that saturated solution so that you add more and nothing is going to dissolve, it looks like nothing is happening. But in reality, there's an equilibrium between dissolution and recrystallization, meaning as fast as stuff is dissolving, those ions are recrystallizing. So some of this stuff down here might dissolve into solution, but then some of these might go back into the solid. And we don't see this, we can't see this with our eyes, but it's this constant equilibrium process. Now, there is certain conditions where we can take this saturated solution and get those that undissolved salt to dissolve. One of the ways that we can do that is by heating it up. We use that delta symbol to indicate we're going to heat it up because at high temperatures, solubility increases. And so now, after heating it up, now there's no longer any solid. And what's kind of cool is if you do this right, and cool it down very slowly, everything stays dissolved. And this is called a super saturated solution, where you've dissolved more than what the numbers say you can dissolve. So just kind of pulling a number out, let's say for a certain salt, the solubility is 1 mole per liter. And then you add 1 mole of it, and then you add just a little bit more, and you see, okay, it's not dissolving. But then you heat it up, and the solubility of that solute will go up in a hot solvent. And so it quote unquote disappears. And if you cool it down slow enough, it will stay dissolved even at the lower temperature. I recommend like just kind of Google some or look at some YouTube videos of super saturated solutions because it's pretty cool. If you leave it undisturbed, it um, it stays dissolved. But you could do something as simple as like barely bumping into the glass, and then all of a sudden all this solid comes crashing out of solution because there was this disturbance. And so again, I just want to emphasize, want to look at kind of a simulation of this, of the dissolving process. But I do again want to highlight that solubility increases as temperature increases. And the opposite is true. If you have a cold glass of water, you're not going to be able to dissolve as much salt as if it were room temperature or hot. So let's take a look at a little bit of a simulation, and I recommend you play around with this as well. So I've posted this site in the past, but this is just if you Google PHET, P-H-E-T, and go to the solubility simulation. And so here we're just going to kind of look at what happens when you put table salt in water. So I'm going to shake this a little bit, and the salt goes into the water, and it dissolves. And sometimes if you look at it a little bit, sometimes the chloride ions and the sodium ions, like very, 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 very quickly, very briefly, look like they're going to come back together and then they just quickly separate apart. And then I'm going to add some more, see what happens here. And so I'm still at an unsaturated solution because I haven't reached that maximum solubility. So let's get a little crazy here and add a lot and watch what happens. All right, notice there at the bottom, kind of in the middle, there is some that has not dissolved. But notice that it's not just sitting there. What's going on? As fast as the sodium chloride is coming apart, there's sodium ions and chloride ions coming back together. In fact, I'll add a little bit more. And so now I'm at a saturated solution because nothing else is dissolving. Now let's kind of take a look at this. Let's compare this to something that's not as soluble as table salt. So these are like slightly soluble salts. So I'm going to just shake a little bit in here. So this is silver bromide. So yeah, that kind of a little bit dissolved. Add a little bit more. That's dissolving. Add some more. I'm not adding nearly as much as I did with the sodium chloride. And look, it's already starting to not dissolve. I've already reached the saturation point with just a little bit. If you want to play with the volume, you can increase the amount of water. See if I can get this to work. And notice when I increase the amount of water, the amount of solid starts to dissolve more. Or I can take away the water, see if it'll work for me. Take away some of the water, and less of the silver bromide becomes soluble. So, like I said, I encourage you to play around with this simulation a little bit and to kind of get used to solubility. And this will be kind of helpful in 102 because you can actually design a salt and you can kind of see what happens when you change things like charge. Charge has a big effect on solubility. You'll learn that next quarter. That KSP value there on the right-hand side is a measure of, is a constant about how soluble or insoluble something is. You'll learn about that as well in 102.